Dear students, in this lecture we will discuss the lanthanide or lanthanide series, name of lanthanides, how pronounced, position of lanthanide in periodic table, and the electronic configuration of lanthanides. It is lecture number 1 regarding the lanthanide chemistry. What are lanthanides? Different books have different viewpoint. The class of 14 elements which follow the lanthanum element in periodic table is called lanthanide series. The lanthanide or lanthanoid series of chemical element comprises the 15 metallic chemical elements with atomic numbers 57 to 71 from lanthanum through lutetium. The colored portion in the given periodic table shows the position of lanthanides. The names of lanthanides: cerium, parasodium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, and lutetium. Dear students, the general electronic configuration of lanthanides is NS2, now see back, N-1, D0 to 1, then go back, N-2, F, and the number of electrons 1 to 14, where N is equal to 6 for lanthanides because lanthanide belongs to period number 6 and period number 6 element contain 6 shells. Position of lanthanide in periodic table. All the lanthanides have atomic weight between those of barium and hafnium and therefore must be placed between these two elements as also proved by Moseley. In many books, this atomic weight is given replaced by atomic number. Barium has exactly the same outer electronic configuration as calcium and strontium, so barium is placed along calcium and strontium. Similarly, lanthanides have very close similarities, so they are placed together. Since all the lanthanides resemble one another in many aspects, so they are placed in a single class or group. These elements also resemble yttrium because of following additional similarities, so these elements are placed below yttrium. Please check the periodic table. In group 3rd B, yttrium, and below the yttrium this class is mentioned. Owing to lanthanide contraction, the ionic radii of yttrium plus 3 is almost similar to Er plus 3. Yttrium generally occurs in nature associated with the ores of heavier lanthanides and resembles to many other lanthanides and their ions. So they are placed together below the periodic table, have a separate position. All the rare earth metals, all the rare earth metals, I repeat again, all the rare earth metals are placed below the periodic table, and these classes are called lanthanides and actinides. How the electronic configuration is written for the elements? It is based on above principle. Above has German origin, translated as construct or built up. On the basis of above principle, the electronic configuration can be written for the elements And the salient features of Abba principle, the main point is the filling of electron in subshells is done from low energy to high energy. The order of energy is calculated by using the formula n plus L. It is called n plus L rule or vice versa rule. If two subshell has n plus L rule same, then electrons are placed in that subshell which has low n value. Otherwise, if two subshells have different value of n plus L, then electrons are placed in that subshell which has low n value. The order of orbitals is from 1s to 2s, then 2p, 3s, 3p, 4s, 3d, etc. Exceptions are there when the stability of orbitals increases due to half filling or completely filling of electrons. It means the subshells which are half filled or completely filled have more stability as compared to partially filled orbitals. Then there arise certain exceptions. For example, chromium 24, copper 29. It is due to the small energy gap between certain subshells and orbitals. How the electronic configuration is written? Generally, lanthanide follow Abba principle, and the configuration of these elements are 4F1 to 14, 5D0 to 1, and 6S2. The lanthanide may have partially or completely filled 4F orbitals, and due to this unpaired electrons in 4F, they show paramagnetic behavior, and if the orbitals are completely filled, then they show diamagnetic nature. The electronic configuration on the basis of Abba principle can be written as shown in slide: lanthanum 1s, then 2s, and moving toward 5D0. These subshells can be arranged into shells, and every shell has different color in the provided slide. The shortcut method for writing the electronic configuration is writing the noble gas core, then the remaining electrons in other subshells. For example, at the bottom of the series, we have shown xenon, the core, noble gas core, 4F0, 5D1, and 6S2. Similarly, the electronic configuration of cerium can be written as on the basis of a principle. The shells are also made, and shortcut way is also represented. Try to write the electronic configuration for all lanthanides and make a trick to remember exceptions, abnormalities to a principle. In next lecture, we will discuss a trick to write the electronic configuration of all lanthanides. Thank you very much.